we will be talking about distance formula. Distance formula actually is derived from Pythagorean theorem. So when we have our triangle, right, Pythagorean theorem says that, remember this is C, right? If I know A and B, I can always find C. If I know any 2 points, I can always, 2 side measures, I can always find the third side measure, right? Which means if I am looking for, let's say, distance in here for the C, I am looking actually for the distance from one point to the next, right? I am solving the measure of this side, which is distance from this corner to that corner, right? This actually I'm looking for the distance. So if I was to write Pythagorean theorem, that says a squared plus b squared equals c squared. If I told you, please tell me what is the measure or what is the distance, if I say this is point A and this is point B, just kind of, you know, give me an example. What is the distance from point A to point B? Well, your job is really figure out what C is, right? Not C squared, just a C. So I know that at this point, if I was to do that, I know I have to get rid of the exponent. And the only way to get rid of the exponent is by taking the square root of that, right? If I take a square root of one side, I know I have to take a square root of the other side, correct? So actually what you're going to do is distance formula that is derived actually directly from this. Let's look at it. Look at it. Distance formula says D, which is the distance, which is also my C, right? Remember, if I took a square root of it, what would happen? It will not be here anymore. You would actually have square root of a squared plus b squared equals, they cancel, C, right? So distance, the D, right, between 2 points. Let's say if I went from this point to that point, is if you take a square, like if I say A, I'm literally talking about the A's. Do you remember when we had our coordinates points, right? We had x1, y1, then we had x2 and y2, right? We're going to be looking at the difference between x coordinates, and remember a squared, right? Difference between x coordinates. Distance goes with difference, right? So the difference between the x coordinates, and always take the second minus the first, that's my a squared for instance, right? Plus the difference between the y coordinates, and when I say difference, right, I'm looking how they're changing. So we take the second minus the first, right? And remember, you're talking about b squared. And what does Pythagorean theorem says? A squared plus b squared equals c squared. And here what we said, if I just want c, I have to take a square root of it. So the distance equals the square root of the difference between my x coordinates, squared, right, plus the distance between my y coordinates, squared. I will show you an example, and I will show you 2 ways to solve this problem. One will be with using regular, if I was to create a triangle and use Pythagorean theorem, and the other one will be if I use the distance formula. I will grab my handy dandy calculator in here. My first step is read my question. How far are you from the other team's base, right? So I want to know how far am I. If I actually decided to change stuff around a little bit, I want to know how far, actually no, it tells me. Look, see, I didn't even read the question. I read the question, didn't read what else they've given me. It says you are 50 yards north and 20 yards east of your team's base. Then you have another team. The other team's base is 80 yards north and 60 yards east of your base. I'm going to plot it on a coordinate plane and see what's going to happen. So I'm going to start in the origin. I'm going to go by tens, because if I went by ones, I would be here for a very, very long time, going all the way up to, what is my y? What is my rise? North, right? Goes all the way to 80. I am not doing that by ones. I'm going to go by tens. This is my coordinate plane, so I can choose whatever I want to do. If I would want to go by twos, I will go by twos. I am going by tens in this situation. I'm going to first plot my team's base. My team's base, all right, 50 yards north. North means go up. From 0 to 50 up, and 20 yards east. I am right here. This is my team's base. The other team's base is 80 yards north, so I go 80 up and 60 east and 60 over. So the question is, how far are these two teams away from each other? Well, I cannot count these really nicely, right? They're not in a straight line, so I cannot really figure it out. But there's one way I can do this. Well, two ways. One, I'm going to use Pythagorean theorem, and the second one is going to be the distance formula. So let's apply our Pythagorean theorem first. So I want to know if I can create a right triangle in here. Let's see. If I follow these lines, here's what I just created, a perfectly right triangle. Remember, these are squares, right? Squares create a right angle. So this is my right angle. If this is the right angle, this one in here, this is the 90 degree, this is my hypotenuse. That's my C. If this is my C, that means this is going to be A and this is going to be B. Pythagorean theorem says A squared plus B squared equals C squared. I have to figure out how many units is A and how many units is B. I can do that. Remember, I went by tens, right? So I go 10, 20, 30. So A is 30 units and B is 10, 20, 30, 40. B is 40 units long. Let's substitute in. A is 30 squared plus 40 squared equals C squared. 30 squared, right, is 900. Plus 40 squared is 1600 equals C squared. If I add these two up, I get 2,500 equals C squared. Remember, I just want to C, so that means I want to get rid of the radical, rid of the exponent. To get rid of square, I have to use the radical, which is also a square root. I will cancel that 2 out, right? The exponent will cancel. What I do to one side, I do to the other side. If you put in your calculators 2,500 squared, remember square is this button in here. I hit that and I will get 50. So using Pythagorean theorem, I figure out that 50 is C. 50 yards is the distance between these 2 points. Let's see if I was to apply the distance formula. If I was to apply the distance formula, if I will get the same answer. I should. Let's see if I will. So this coordinates of this point, right? This is my team. The coordinates are on x-axis, it's 20. On y-axis, it's 50. Right? This is my first x and first y. Please make sure you name your points x1, y1. This point is the other team. On x, it's 60. And on y, it's 80. This is my second point, x2 and y2. If you remember, distance formula is derived based on this, right? If I was to take a square root in here, to cancel out the exponent, right, to get rid of the square, I have to take a square root over here. The A talks about the difference between my x coordinates, right? So the difference is take the second x, subtract the first x, make sure you square it, plus the difference between my y coordinates. So I take the second y, subtract the first y, and square it. If I was to do that, that should give me the distance between these 2 points, right? Or the hypotenuse, the C. Let's plug everything in, let's solve it, and let's figure it out. So, square root of x2, what is my x2? 60. Minus x1 is 20. Squared. Squared. Plus y2 is 80. Minus y1, which is 50. And don't forget, right, it's square. Equals my distance. Order of operations say, take care of your parentheses first. So I have a square root of 60 minus 20 is 40 square, plus 80 minus 50 is 30 square, equals my distance, right? Order of operations say, take care of your exponents. So 40 squared, right? So 40 times 40 is 1600. We all should know that by now, so I don't think I have to show you how to do that on a calculator that much, but let me kind of move this back a little. So I've got 1600 plus 30 squared is 30 times 30, which is 900, equals my distance. Let's add these up. I have a square root of 1600 plus 900 is 2500, equals my distance. And square root of 2500, if you don't know that, please do use your calculator. It should be 15, so 2500, if I hit the square root over here, I will get 50 equals D. And did I get the same answer? I sure did. So this is the way, if you were to use the distance formula, it takes a little bit more steps. Then you also have a way to create a right triangle on your coordinate plane if you want. Name your points, name your legs, A, B, and C, and you use Pythagorean theorem. It's your choice really what you want to apply. Thank you.